Hello all. In this video I will show you how you can use Codesys for our PLC programming. You've already downloaded our Codesys version, which is version 3.5 Service Pack 18. You have downloaded that from an internal site, and I'll just start it from here. I'll type Codesys, and you see that I still have some older versions, but it's the last one that I used. So I'll start it. It will take a while to start up. And after it has started up, you will see some news from Codesys, which you can read if you want to, close it if you want to. And you see some recent projects, which I had a lot, of course. And you can create a new project, open a project, or I don't know what it is. So first I'll take this project, which is a structured text project, and I'll show you some things that you have to keep into account and that you can use while making the assignments. Okay, this should not happen in your case, which is something to do with versions. Okay, well, what does it have? It has more or less the same windows that you're used to when using, for instance, the Kyle IDE, but it has some things extra. You see a toolbox over here. There are things like visualizations, which will show properties, which tells you properties about items. Basically, to start working with Codesys, you only have to deal with things that have to be added under pay or use programming organization units, and we have a standard PLC program that will run, and it will run in a so-called task, as you can see. And when I build the program, and I'll first make a comment of this, and the comment is different than you're used to. As you can see, this is not working. It says an unexpected token. So comments are different than you're using in C++. We'll take test one as a comment. Now you see the curlies, or the red line, dotted line is gone, which means that I could build the program. Well, okay. First left, on the left hand side, we see devices, and we see here that is some kind of control win PLC, which means that it is a PLC that will run on your laptop, like we do here, of course. And when you press the right mouse button, you see that it's in simulation mode. If I switch simulation off, you see that the text here is from italic back to normal, and when I use simulation, it gets back to italic again. And when not working on the real PLC, we will run in simulation. And what's also happened during installation is that there is a soft PLC running on your laptop itself, which runs for about 2 hours and then will stop, and you have to restart it again. And what it does, it has a program, which is, as you can see here, the program, and we have sometimes visualizations, which is not in this program present. And when using visualizations, you have a graphic HMI that you can see in this area, and which you can use to press buttons or make lights or whatever. And that's only present in some of our simulation assignments, although it will be present in our program for the Festo project. Okay, what you can do with this tools is that you can build it, and to build it you can say generate code, and then you see below that it's being built, and it has some messages telling you something about size of the program, etc. And it should be important, or it is important, that you have no errors. And I can introduce an error very easily. Type something, I do build generate code again, and it says something like an expected semicolon, and when I double click on it, you can see that it will also put the cursor somewhere around where the error is, and also it says here this does nothing. Yeah, okay, so let's do that again, and you can clean. It says that of course that it's not possible to use it anymore. We'll get back to that later. And when I want to debug the software, I'll have to load it, download it, or upload it somewhere to the PLC. Well, now in this case, it's a simulation, but still I have to go online. And then it says something like this. It says that the sim device, the simulation device, application, and application is the program that's being built during the build process, doesn't exist. So want to create it, yes, which means building, and then do a download. Now you see that it will be rebuilt over there again, and then I get in the editor itself, again in the debugger, sorry. And as you can see, it is not running yet, and I can do several things like just run, and then it will run as it says here in simulation mode, and it will do not much, of course, except giving A the value 14, as you can see, and B the value -5, and that's it. And I can also stop it, and it will stop somewhere. These things are breakpoints, or possible breakpoints. With the right mouse button I can say toggle breakpoint, and in this case the breakpoint will be here. I can run again, and it will stop at the breakpoint. And as you can see, I can also step over by using F10, or into a function by using F8. I'll be using F10, and you will see that will go all over these lines. It executes one line per step. Well, this is not very useful, so I'll have to log out again so I can edit my computer program. And what we can do is we can make extra functions or function blocks. Function blocks are more or less like class objects. You can create a function block, and a function block has internal memory, and during every program run cycle, it can keep variables with values. And functions is just like also a function in C++. You pass values to a function, and it will return a function somehow. Okay, in this case, we would like to create some kind of function, and I will call it test in this case, and it will take two values, add it somehow, and then return the value. Well, for that I need a function test, which is not existing right now. Under the POUs, we press the right mouse button, add object, and then we say POU, and as you can see, you can choose between a program, which we already have, PLC, PLG, a function block, or a function. Well, let's take a function now. Name should be test, of course, and it should return something. No, let's return an integer in this case. We have ints here also that we pass to the function, and we have different kind of programming languages, and we will use structured text in this case, which has a C-like language syntax. Press add, and there we have the function test. We have var input possibility, and we have vars here. Okay. Will it work? No, it will still say there's something wrong, because we need to pass two variables of type int. So let's create them, and they are seen as input. So x, y of type int. You see that the problem is gone there, and of course also we have to return a value like we said. And returning a value in a function means that you just simply take the name and you can give it a value. Well, this case can be very short because I can say x plus y, and that's it. So what it does is it takes the two parameters that were being passed to the function as input, add them, and then return the value as the end value of this function, so that when I run it, it will end up in C. Well, again, let's go do a build just to be sure that it has no errors. Go online. It says something changed, so we have to upload it again, download it. Well, you have several options. You can just log in with online changes, which means that it will update the program as far as possible and keep in memory what should work already, or do everything with a new download. Well, in this case, it doesn't matter. And there we are. Let's simply put a breakpoint there, active. Let's run, and it will stop here. And as we can see, of course, these lines have been executed. 14 and minus 5 are already in A and B. And now we are going to execute test. And we do that by, for me to see if everything's going right, step into, so F8. Now, then we are in our test function. We see that X and Y have the appropriate values, minus 5 and 14, as you can see. So that's okay. It will add it, step over in F10. Well, of course, the addition is 9. I go back, next step, and then you can see that C becomes the addition of the both values over there. And of course, if I run it now all the time, nothing will change, of course. What I also can do is I can change values here during the debug session. It does not work by simply clicking here as you were used to using Kyle. I can do something like here, like 10. And as you can see, it does not have the value yet, so I have to do something more. And I have to say write values. And then you can see that the values that I prepared over there are written to B. So now I have 10 and 14 that will be added, and then when I step over it using F10, you see that it's been added. So as you can see, you have the same possibilities as when using Kyle. You have functions or function blocks, and I'll show you also the use of a function block. You have functions like I showed you here, and you can debug, and also you can during a debug session put breakpoints, and on a breakpoint you can also change values of variables in your software. Okay. Now what a PLC does, and it's not being shown here, is it reads input values somehow from an external system. Then it will run the programs as we are doing here, and then it will put the output values. That's something that you will learn also when programming the Festo system. So let's make a function block. We do also here an int, and of course you have several types. We will say d equals, for instance, we call it counter, and we'll pass nothing, and we can make a new POU, and in this case I'll make a function block, structured text, and I made a mistake because a count function block does not return a value, so I will put D over there. again, add object, POU, function block, and structured test again. And as you can see, it has some things that we won't use. And by using this, I'll create our function block. And as you can see, I used the wrong name, and the name is here. I can change it over here, but that will not have the effect I want. Take the properties here, and then I can say counter. Yes. I have to replace it over everywhere, and then you see I have a counter, and it has a counter here. Well, I prefer to use names that are preceded by FB. So I know that's a function block in this case, and function has no things prepended. So I have a function block FB counter, and as you can see here, it's also changed. Well, the moment you are going to use function blocks, you have to create an instance of the function block like you're used to in C++. So I'll make some kind of counter, which is of type FB counter. And then we are using it like this. We are passing a value to counter, so we also have to create some of our input here, which is z of type int. And we have some output variables, as you can see here. And we have local variables, like we also had here. So var and var is a local variable that we could use here. For instance, we could have said p of type int, and then did something like p equals x plus y, and then said okay, we return the value of p for the function. And here, if we want to put values outside the function block, we also had to specify a variable for the outputs. And these are the local variables, internal variables. And a function block does the following. When we have created an instance of the function block and we call it, then when we call it, the code here will be executed, and all variables, local variables of this function block will be like we call persistent. So they will not get lost every time that we run the cycle. So let's make a count value of type int, and we can give it a start value also. And in this case, I will not need an input, but I need an output. And what I will do is I'll increment the count value. So count value gets 1 up, and just to be sure that I can read it, I'll say count value here, and D in this case should be sorry, do nothing, and I can say D is counter.a. Let's do it like this. I have no input anymore, so I hope that I'm now ready. Just make an example on the fly, of course. No errors, as you can see, a lot of messages. So let's just go online. Yes, login. And we can also see the internals of our function block, which is nice, of course. And when I press run, well, you see that the counter is somehow counting up an A also, and also our D, of course. I'll put a breakpoint here. Okay. And in this case, we have a D value of 886. And the counter is already one further. Oh yeah, sure. Because I want to put my breakpoint over there. Run over there. That's better. So D got the value of counter A, which is, of course, 887. And now I stopped here and we will go into the counter itself again by entering using F8, F8, and it will increment the counter value, F10, and then it will make A, which is the variable that I can read from outside, make it equal to the count value, F10, F10 again. And as you can see now, counter has executed, so it's 888, and D has not got the value from counter A again. And by pressing F10 again, it will update D. Well, there are other possibilities to call to create this construction, but I think this is the easiest way. At least you know what you're doing. You're calling the function block, and then yeah, you get what you need from the function block itself. You can have multiple output variables. You can also have multiple input variables over here if you want to. Just play with it, but this is more or less basic usage of Codesys, building stuff, going online, debugging, and one of the things you can also do, which I have not shown yet, is go online and perform some kind of resets where everything will start from the beginning. Well, okay, that's it. Have a lot of success while making the assignments, and until we see each other again.